Yes, good morning, good morning, good morning. All fine? Yes, all good. Yes, good morning, good morning. Okay, so good morning. All good. Reunion when? Okay, for you, reunion will be okay after selection next year. And sir, please explain the graph of three quantities. I have doubt. Which one, to be precise, means so many graphs actually I have told. Yes, sir. Good morning. Love from previous batch student. Okay, Mohit bhai, relax of boys campus. Okay, good. PVT. Okay, PVT means previous batch enjoy. Okay, life is chilling. Yes, good. So PVT, all the three things are there. Means comparison based means this question you are asking. I think you are asking this one here. If I say this is the P, and here if I say T, and I'm going here, this is the V1 and this is the V2. Are you asking this one? Yes. Because here PVT is there. This one. So in this one, I said that, okay, we can use, we can draw the line like this. And if you draw line this way here, okay, if I, okay, because here PV equal to nRT, moles they will give you constant, still three variables are there, and three variable you cannot compare at once. So you will draw line this way, and when we are putting line this way, then we can say corresponding to this one, this will be the temperature T1, and for this one temperature T2. When you are putting line like this, we are making pressure constant. It means this constant, so V proportional to T. From here we can say in this one that T1 is more than T2, which implies V1 more than V2. Okay, this is the first method here. Okay, second method for these graphs is, okay, that in this one, okay, graph is given like this. This is the P, this is the your T, and these are the two, okay, given V1 and V2. We can say PV equal to nRT. I will write here. Okay, first method is applicable always, okay, but second one is only applicable for the straight line. Okay, only for the straight line. So I will, okay, go for this one. P is basically y-axis. Okay, P is your y-axis, and T I can say axis. So y equal to, we can write n r by v into T is the x. So we can say y equal to how much, your mx. So if you say, okay, if we say slope here in this one, then you can write, sir, slope is actually equal to, slope which is actually equal to m, that is the nr by v. Means if slope and volume relation is inverse for this thing. So here slope is less, it means volume will be more. So we can say V1 is more than V2. This is the slope method and this is the line method. This one is applicable everywhere, and this is only applicable for the, okay, only applicable for the line. Clear? Yes. But I will say that use this one. Okay, you can make one parameter constant out of three, and then we can compare. It will be much better. Okay. So in last class we started concept of mixture, I think. Concept of mixture. And in concept of mixture, how many questions we have done? In mixture, how many questions we have done? Only one, I think. Okay, so now we'll write some more questions. Okay, so I hope you are ready. Means mixer means basically how I can mix. Actually, I can mix in one container. Okay, in one container I can mix. Okay, or I can mix in the other okay, container. I can join the container. Okay, so we'll add here and we'll go for the next one. So in one container already we mixed. Now we have to go for the joining of container. So if I say, right, two identical bulb two identical bulb. In bracket you can write P comma V comma T. P comma V comma T. It means pressure, volume and temperature is PV T. Two identical bulb. Pressure is P, volume is V, temperature is T. Okay. So two identical bulb. PVT, and here also PVT. Okay. Now, if I say whenever I am joining, okay, like in this container, okay, we have a huge mole, but volume is very less, okay, so much, okay, means molecules are more, but volume is very less, and then another container, size is big, but moles are less. So you can say ultimately molecule will move from high pressure to low pressure, okay, and this movement will be continued till pressure everywhere becomes same. So one thing you have to remember that in the mixture, okay, whenever we are joining the container, in both the container, which parameter is going to be same? If I join the container, okay, then which parameter will be same in both the container? They will give the option P, they can give V, they can give the T, they can give something else. What parameter is going to be same all the time? Pressure is going to be same always, okay? Pressure at each point will be same. This is the one key point that you have to remember, that pressure will be same everywhere in this question. Pressure everywhere will be same, okay? All the point will be having one thing, that is your pressure. So everywhere pressure is going to be same, okay? So whenever I will do mixing, right now, okay, right now if I say na this, okay, okay, right now this is not mixed. These containers are not joined, okay? Right now not joined. But if I join these containers, then which parameter will be always, which parameter will be always constant? We can say pressure will be everywhere. At each point, pressure is going to be same, okay? At each point, pressure is going to be same. Clear this thing? Other things can vary, okay? Pressure only will be same, okay? So, two identical bulb, okay, in bracket PVT are joined together if first bulb kept at temperature T and other at temperature 2T, first bulb at temperature T and other at 2T, find final pressure in bulb. Find final pressure in the bulb, okay? So we can say final pressure, if here P dash, then everywhere at any point, okay, in this combined container, P dash will be there. Here also P dash, here also P dash, okay? And tube is always very thin, okay? So tube we always neglect. Here volume will be V, here volume is V, because volume of the container will not change, okay? So this volume is V, here also V, here V, here V. But they are saying in that question that this one I am keeping at the T, this one I am keeping at the 2T. They can keep at the different temperature, that can be changed, okay? But pressure everywhere will be same, okay? Now if I say when we will join, then whatever the moles are there, earlier in this one, suppose here 2 mole and here 3, okay? Suppose if I say here, okay, some moles are there, here 2 mole, here 2 mole, okay? Later on, if you heat, then what will happen? Some of the moles will move from here to this container to this container. But overall number, if I say, earlier if you are having 4 mole, later on also you will be having only 4 mole. Means earlier if here we have 2 mole and here 2 mole, then what will happen? After some time there can be 3 mole and here 2 mole. Because molecules are not going outside. There is no leakage. And no molecules are coming from outside, okay? No leakage. So we can say if molecules are not going outside, molecules are not coming from outside, so overall moles before in a mixture will be same or changed. If I say moles before and after, moles before and after will be same or changed? Moles before and after will be always the same, okay? So in the mixture, 2 things you have to use always. Number 1, moles before and after same, and pressure everywhere will be same, okay? Moles, overall moles, initial equal to final. So I can see here in this one, and after, number of mole after, okay, equal to and before, okay? Means initial mole equal to final mole, before equal to, okay, after we have written. So this thing we have to use every time, and we have to keep everywhere pressure same. These are the 2 things you have to use. In any question, answer will be there. So now we can say, initially if I say in this one, how many moles? For the mole, we'll use the formula PV equal to nRT. So from here I can say number of moles given by PV by RT. So we can say for the first, okay, in the first bulb, moles will be how much? Your PV by RT, and here also PV by RT. So we can say total mole initially PV by RT plus PV by RT will be how much? Your 2 PV by RT are the initial mole, okay? In the first container PV by RT, in the second container also PV by RT, okay? Then we'll write after joining. Once I join here, okay? Once I join, then what happens? Here moles will be P dash V by RT, and here mole will be P dash V by, okay, R2T, because temperature is 2T, so I can write here P dash V divided by RT, and here I can write your P dash V divided by 2 RT, because here temperature is 2T in this one, okay? So now we can write here RT will be cancelled, okay? And then VV also will be cancelled. That becomes your answer. So P dash plus P dash by 2 equal to, you can say 2P. P dash plus P dash by 2 is how much? Your 3P dash by 2 equal to 2P. We need to find the final pressure P dash. So P dash becomes 4P by 3. Can we write the next question now? Next one. So everywhere you have to do the same thing, okay? Initial mole and final mole will be same, and pressure throughout the container will be same, okay? Throughout the container, okay, it will be same. Okay. So one question I am going to give you, okay, you have to solve exactly same pattern, slight changes I will do, little bit changes, and then we have to do the things, okay. So let's see how many people are going to get the correct answer here. So next one for you, okay. I hope you got the, okay, what you have to do in any question, everywhere throughout the container pressure is going to be same. Throughout the container pressure is going to be same everywhere, and initial mole equal to final mole. That's it, okay? Same principle you have to use everywhere. Answer will be always. So suppose I have given container like this, and in this one they are saying, okay, that here pressure is 2P, volume is V, and temperature is T. And then another container, here pressure is 3P, volume is V, and temperature is 2T, okay? And now what they are doing, okay? After joining, find final pressure if both are kept at a temperature, if both are kept at the temperature 3T. If both are at temperature 3T, then you have to solve this thing here. So we can write in this one, okay. If both are at temperature 3T, so yes, here also 3T and here also 3T, and this one is basically your, okay, pressure we can say P dash, and this volume is V. Here also pressure P dash and volume V. So final pressure you have to find, okay. Make it fast. What will be the answer? Yes. What will be your answer? Make it fast. Same question, same principle, there is no change at all. Yes? Anyone got the answer? Send answer, not anything else. Tell me the answer for this one. 15 by 2P, 21. 21P by 4 is correct. 21P by 4. 21P by 4 will be the correct answer. 21P by 4 will be the correct answer here. Okay. So now we'll do the same principle we have to use, and before equal to and after, we can say and after is going to be and before here. And now I can say before actually mole in this one, we can write pressure is 2P, so we can write 2 PV by RT. So I will put here 2 PV by RT, and here I can write in this one 3 PV. So 3 PV divided by, we can write how much here? 2 RT. Okay, this is the before. And in later on I can say pressure becomes P dash everywhere. Okay, this thing you have to remember, everywhere pressure is going to be P dash. Okay, so we can say P dash V divided by 3 RT, and here also I can write, okay, they are saying P dash V by 3 RT. Okay, so we can say RT will be, sir, cancelled everywhere, and here P dash VV also cancelled. So this one becomes P dash means 2 P dash by 3, and equal to, here I need to add, this is the 2P plus 3P by 2. And 2P plus 3P by 2, if you add, then we can say either I can make the same base, either I can do the LCM. This will be into 2 into 2, 2, okay, 4 and 3, 7P by 2. Okay, so I can write now P dash. So P dash will be equal to how much here? 3 and 7, there are the 21. So we can write 21 P by 4 is the final answer here. Okay, 21 P by 4. Clear? In this one, what I am saying, and before and after must be same, and pressure everywhere, okay, after mixing will be same. So here P dash, here also P dash, here VV, here 3T, here moles. In this box we get 2 PV by RT. In this box we can say what's your 3 PV by temperature, 2D, so 2 RT, and now we can see here P dash V by 3 RT, here P dash V by 3 RT, and then solution. Okay, so 21 P by 4 is the correct answer. Can we write the next question now? Next one. Ready? For next question. Okay. So if I give you anything, means only thing, like right now I was having the same volume. So in the next question I will change the volume. I will say volume V1, and I will take another volume V2, means volume I will change. So things will remain same, question is not going to change, method is not going to change, just volume I will take V1 and V2, that's it. Okay. So let's have next question, and now in the next question I am going to take volume V1 and V2. Okay, so volume will be changed to V1 and V2, and then you have to do the same question here. Okay, so I hope everyone is getting this thing, because next to next question I have to ask to you. So they are saying that in this one, okay, this is the P1, and here volume is V1, temperature T1, and this container I can say, okay, it is the P2, it is the V2, it is the T2. Okay, and they are saying after joining final pressure and temperature becomes P dash and T dash. They're asking find P dash by T dash. Okay, this thing we have to find P dash by T dash. So they say after joining, in this question they have given pressure as well as temperature. Usually what happens, they give the temperature and they will ask the pressure, or they are giving the pressure, they are asking the temperature. But in this question, both they have given that P dash and T dash, okay, and they're asking P dash by T dash. So we can say after that, if you make the diagram for this one, then this container, okay, we can say everywhere pressure is going to be same P dash, here also P dash. Volume will be V1, volume will be for this one V2, and temperature here T dash, here temperature T dash. You have to use the same method here. That's we can write and after equal to and before. So I can say before how many moles are there? We can say in this one P1 V1 by RT1 we can write. Okay, so you can say sir P1 V1 by RT1, and here we'll write in this one P2 V2 by RT2. If I say after, then you can say after in this one P dash V1 by RT dash. So we'll write here in this one P dash, okay, V1 by RT dash, and here I can write P dash V2 by RT dash. R you can say sir cancelled from everywhere. After this nothing is going to be cancelled, so I can say sir here P dash by T dash is asked in the question, so that is the common. It becomes V1 plus V2 here, and here I can take LCM if you want to take, and this thing depends on the options. Sometimes they will not take and sometimes they will take. So suppose if I take LCM, then we get this thing becomes P1 V1 T2 plus P2 V2 T1 divided by I can write here T1 T2. So we can write final answer P dash by T dash, which is asked in the question, P dash by T dash equal to, we can say, P1 V1 T2 plus P2 V2 T1 divided by, we can write here, T1 T2 V1 plus V2. So when options will be appearing in the examination, then this will appear as the very tough question. But actually, if you see, this is a very easy question, just one line we have written, and then we got the answer. Okay, sometimes options are tough, questions are not tough. Okay, like option will be big, question will be very easy. Like this one is there. Can we do the things like this? Each question also we can do. Yeah. Okay. Good. Storm Gaming Telugu. Okay. Are we ready for next question? Can I give you one question exactly based on this thing? Exactly based on this. Okay. So this question you have to repeat. Okay. If I take container of, okay, means both the container volume is your same. V, okay, means V1 equal to V2. V1 equal to V2. That is the V. If I take, then same question you have to repeat. Okay. I am taking the next page now. They are saying here in this one that if V1 equal to V2 equal to V, then P dash by T dash. Same question, there is no change. Then P dash by T dash. And okay, this will be the answer. This answer you have to match. Okay. P1 by T1 plus P2 by T2. Okay. If you are getting this answer, this is the answer. You have to match this one. And don't put in this previous, whatever the previous question we solved, don't put in that formula V1 equal to V2. Solve again. You have to do again. Okay. Don't put the values in that previous formula. Solve again. This question is just given only for the practice. So do that way. Okay. Again, n before equal to n after. And this will be the answer. Okay. See whether you are getting or not getting. Okay, so can we move forward? This is just home. Okay, you can try now also. It will take just, okay, 1 minute, not 1 minute also, 30 seconds only it will take. So we'll move forward. Matching? Yes. Okay, this one matching. Done. What will happen? Okay, same principle is there. I'm saying that don't put in this one. Okay, so you don't have to take this LCM here. Okay, you will keep as it is, and okay, and okay, as it is, and V1 plus V2 will become your 2V, and here this is the your V, this is also your V, and this is the V. So what will happen? Basically, your okay, this become here in this one your 2P dash, because VV will be cancelled. So 2P dash by T dash will be equal to here P1 by T1 plus P2 by T2. This is the thing, and then we can say P dash by T dash will be your half. Okay. Okay. So write container, a 4-liter container, a 4-liter container contains some gas at atmospheric pressure. Okay, contains some gas at atmospheric pressure. A 4-liter container contains some gas at atmospheric pressure. Okay, means we have this container. In this container, what we are having basically, or 4-liter is the capacity of this one. Some gas is there, but pressure they have given 1 atm. Okay. Till now we had done all the question. We were joining with the another container, and that another container was having some. Volume, some means another container was having some gas. Okay, now in this question I will take another empty container, means we'll join, okay, with an empty container. Empty means nothing will be there in this container earlier. Okay, now it is joined. Now it is joined with an empty container. Now it is joined with an empty container. Okay, container of volume 15 liter. Now we are joining, okay? This is the 15 liter, but in this container there is nothing, okay? There is no gas. So how many moles are there in this container? You can say, sir, there is no mole actually, okay? Only in this container mole are there. And if you join, then what will happen? Then moles will distribute, okay? Some moles will be in the first container, some moles in the second container. Then there, okay, some gas here and okay, some molecules here, some molecules will be here. But initially in the second container there is no molecule, okay? So volume is 15 liter given. Find final pressure. Find final pressure. In this question they have given temperature is constant, okay? Means temperature is always constant. They have given this thing. So now we'll use the same method here. Sir, nothing. We'll use n, okay? After equal to n before I will use, okay? And after equal to n before. So if I say before, actually in the first container how many moles are there? We can use PV by RT, okay? We can use PV by RT, okay? Yes. So now we can write pressure is how much? Your 1 atm. 1 atm is the pressure. Volume is how much? Your 4 liter. And RT, I can write temperature is a constant here, so I can assume the temperature HT. And I'm not converting this ATM, okay? Because we know I will solve in the ATM, I will get answer in the ATM. Volume will be cancelled, so no need of conversion exactly, okay? So I will write here this one, that's 1 into 4 divided by RT. In the second container, moles are 0, okay? Second container is empty, so nothing is there, okay? Only in the first container moles will be there, so we have used PV by RT, pressure 1, volume 4 by RT, okay? And not converting will be cancelled. Then after what happens? After that we can assume pressure becomes, after it will become like this. So here also some, okay, it will become like this. I'm making some what, okay, a small diagram. Here pressure P dash, here also pressure P dash, here 4 liter and here your 15 liter. Temperature is still same, okay? So now we can write here in this one, so this will be the P dash into 4 divided by how much your RT, and in the second container I can write P dash into 15 by RT. You can see, sir, RT will be cancelled. So here 15 and 4 is your 19, okay? So you can say 19 P dash equal to how much your 4. So P dash we can write your 4 by 19 atm, okay? This is your answer, final pressure. Can you do this way? Sometimes what will happen in the examination, they will not ask final pressure, and they will ask, okay, in the examination, change of pressure. Final pressure will not be asked, change of pressure they will ask. And if they are asking change of pressure, then what we can write here in this one, change of pressure delta P, that will be, generally we write final minus initial. But if you see final pressure is less, initial is more, okay? So we'll write here initial minus, okay? So initial is 1 minus 4 by 19, that actually becomes here 15 by 19 atm, okay? They might ask this change, okay? They can ask, sir, this change in the Pascal. If they're asking change in the Pascal, then we can write 15 by 19 into 10 power 5, that will be in the Pascal. 15 by 19 into 10 power, okay, 5 will be in the Pascal. And if I say in the mm of Hg, then we get in the mm of Hg will be 15 by 19, okay, and 1 atm is basically your 760 mm of Hg, okay, mm of Hg. So we can say this becomes 19760 will be how much your 4 times 40 here, 4 no 40, and 15 into 40 will be how much your 600 mm of Hg, okay? So you can find this change in the mm of Hg as well as in the atm as well as in the Pascal. Here we have used one method. I will tell you for this question one more method, okay? This n before equal to n after is valid everywhere, okay? Everywhere we can use n before equal to n after, okay? Means whatever the questions are there, n before and after we can use. And before and after, okay? Second method is you will say, sir, PV equal to nRT. And if PV equal to nRT is there, then in this question we know as, okay, as a whole, moles are constant, temperature constant, okay. So as a whole, this PV is also going to be constant, and if PV is constant, then we can use P1 V1 equal to P2 V2. So as a whole, P1 V1 equal to P2 V2. So initial pressure is 1, initial volume was only 4 liter because gas was only in this container. So in this container only 4 liter. After that pressure we have to find, and after joining gases in both the container. So in both the container, what is the total volume? You can say 4 plus 15 means 19. So now we can write P2 becomes here, and this one 4 by 19. But this one we can only write whenever they have given the temperature constant, and this one we can use always n before equal to n after, okay. So that's the difference. If temperature constant, we can use P1 V1 equal to P2 V2, that's the Boyle's law. Otherwise, okay, we can use this thing everywhere, okay, and before equal to n, after valid every time, okay, in any question. I hope this thing is clear. This one written, finished, ready for next. Next things we can write. Yeah, okay, yes. So next, if I ask that when molecules are there, molecules are at the rest or they keep on moving randomly. Now questions of mixing we can do, okay, 4 or 5 questions are more than enough to do here. You can try those questions, we'll get hopefully all the questions. So molecules keep on moving randomly, okay, here, there, like this, okay. You can say, yes, they follow the Brownian motion, they keep on moving randomly, okay. So whenever they are moving randomly, they will of course collide with the walls of container, okay. So we can say in this one that molecules are basically moving like this. So like this molecule is going, so it is having some mass as well as velocity. We can say its momentum will be mv, and that will be reflected back with the momentum in the opposite direction. So I can say minus mv. You can say molecule is going with the momentum mv and then coming back with the momentum mv. What are the change of momentum? So we can say change of momentum is your final minus initial. So minus mv, that actually becomes here minus of 2 mv. If I say force, then you say, sir, rate of change of momentum, delta P by delta T is the force. Delta P by delta T is the force, okay. So molecule will apply some force on the walls of container. You also know that if you hit some, okay, you take any ball or something, if you hit on the walls, it will apply some force, and then you know force per unit area is the pressure. So pressure is nothing but the force per unit area. This is the your pressure, okay. So now we can write here in this one, molecules keep on moving randomly, and okay, they collide with the walls of container. As a result of this, they change or they transfer momentum to the walls. They transfer momentum to the walls of container, and because of that pressure is there, okay. So this is the region of pressure. So you can write one line, molecules move randomly, molecules move randomly, molecules move randomly and collide with the walls of container, and collide with the walls of container, collide with the walls of container, collide with the walls of container. So transfer momentum to the walls, transfer momentum to the walls, transfer momentum to the walls, that causes pressure on the walls of container, that causes pressure on the walls of container. In questions they will ask what causes pressure on the walls of container. We can say what causes pressure on the walls of container? Transfer of momentum or change of momentum, because molecules keep on moving randomly. So transfer of momentum, or okay, transfer of momentum, or we can say your change of momentum, collision with the walls, that causes pressure on the walls of container. These are the steps of derivation. Here we are writing this heading is basically pressure, okay, exerted by gas, okay. This is the heading, We are writing for the pressure exerted by gas. So first step is to find change of momentum, then to find the force delta P by delta T, and then find the pressure using this force by area. So I'm not deriving this one, I'm writing directly. This pressure value we get here 1 by 3 rho V RMS square. Hopefully you know that P is the pressure here, everyone knows, okay? And we can say rho is the density here, and we can say V RMS, you know, that is the root mean square velocity, okay? So P equal to 1 by 3 rho V RMS square, okay? Now if I say from the pressure, they ask only variation of the formula. So I can write this one as 1 by 3 rho is the density, so mass by volume into V RMS square. I can write like this also because mass, you know, we have written small m into capital N. If you remember in the last class, small m into capital N. So I can write here small m into capital N divided by V into V RMS square. N by V. Can you tell me the N by V? N by V is known as which density? N by V. If you remember. Because mostly people forget this thing. What is the N by V? Mu. It is the mu. It is the your number density. Okay. So we can say this is the mu half means 1 by 3 m into mu into V RMS square. Okay. Mu is not linear density. Mu is the number density. Okay. Mu is molecular density, or we can say number density. So they can say they will give you some formula. Which of the following is incorrect? So this is also correct, this is also correct, and this last is also correct, okay? All three are correct here. If they want to ask any question on this one, question is actually nothing, okay? Means they will give you the density. They will say the density is, suppose your 2 into 10 power, okay, like 4. They have given your VRMS. Suppose VRMS is 2000 meter per second. We can say 2000 meter per second is basically 2 into 10 power 3 meter per second. They're asking the pressure, so we can say pressure equal to, let me make it 3. Okay, so we can write P equal to 1 by 3. Rho is 3 into 10 power 4, and this becomes a square, so 4 into 10 power 6. 3 cancel, and this is the final your 4 into 10 power 10, and this is the Pascal. So actually, not numerical is nothing here. Okay, numerical will be very simple one. Means density will be given. Sometimes they will give you mass, they will give you the volume. Then also we can solve. Okay, so just formula based question. Formula you have to remember that the P equal to 1 by 3 rho VRMS square. P equal to 1 by 3 rho VRMS square. Density we can write as mass by volume, and capital M, total mass of the sample, is your M into N, and N by V is your mu. Okay, N by V is the mu. Okay. So are we ready for the next thing? Okay, so now we'll go. Okay, yes. So if I say in the next page that here, okay, pressure is 1 by 3 rho VRMS square. Pressure is 1 by 3 rho VRMS square. And if pressure is 1 by 3 rho VRMS square, then you can say, so in this one I can write, okay, VRMS, okay, VRMS. So we can write from here, VRMS equal to, okay, you will say, so this will be the 3P by rho, VRMS square 3P by rho. So if I say square means this side root I have to take, so it becomes your VRMS equal to root of 3P by rho. And you have to remember, because VRMS is always very important. All the time VRMS questions are important. Okay, so we can say VRMS. This year, if you remember, question was from VRMS. Okay, so VRMS equal to 3P by rho. But if I ask one thing here, VRMS full form is root mean square velocity. Okay, I can write here VRMS means, okay, VRMS means root mean square, okay, velocity. Okay, I will define also in the, okay, maybe today or maybe in the next class we'll define. First we'll complete the questions, then I will say, okay, so root of 3P by rho. If you remember, I have told you this formula, rho equal to PMW by RT. I said this formula we have to keep in the mind. Density equal to PMW by RT. So now from here I can write in this one that if density equal to PMW by RT, if density is PMW by RT, so from here I can say P by rho. So you say, sir, P by rho, if I say, so what is the P by rho? P by rho, I can write how much in this one? Yes, sir, RT by MW. Okay, P by rho, RT by MW. So here I can put in place of this one VRMS. So first formula of the VRMS is this 3P by rho. Now P by rho I can replace with the, so 3RT by MW. Then you will see, sir, one more formula is there for this one. There is your rho equal to, okay, Pm small by Kt, and from here also I can say P by rho. So P by rho will be equal to Kt by small m. I can put this thing also. So we got here three formula: 3P by rho, 3RT by MW, and 3Kt by small m. All three formula you have to keep in the mind. VRMS equal to root of 3P by rho, root of 3RT by MW, as well as root of 3Kt by small m. Okay. Yes. Then can we keep all these formula? All three you have to remember, okay, not only one. VRMS, root 3P by rho, root 3RT by MW, root 3KT by small m, okay? So if I say speed, energy of ideal gas depends on temperature. Energy of ideal gas depends on temperature. And cardiac energy is how much? Cardiac energy is half mv square. Cardiac energy is half mv square. So I will say that if I change the temperature, then cardiac energy will change. And if I am changing the cardiac energy, then half mv square will change. Mass of the gas will be constant, then only velocity will change. So velocity will change whenever energy change, and energy will change whenever temperature change. So VRMS will depend on which factor? Yes, sir, VRMS will depend on energy. Energy depends on temperature. So VRMS depends on temperature. Okay, directly if I say theoretically that if I am changing the temperature, if temperature change, then cardiac energy change, and if cardiac energy change, then only velocity will change. So velocity will change whenever energy change whenever temperature change. So VRMS and temperature is the direct relation. From the formula also clearly visible, VRMS proportional to root T. If I say VRMS is proportional to root P, true or false? If I write anywhere this thing, VRMS proportional to root T, I can say there is no problem, okay? Because MW is always constant. MW constant, molecular weight will be constant, so I can say this thing, there is no problem. This is correct. Okay, VRMS proportional to root T, correct. But can I say VRMS proportional to root P, true or false? VRMS proportional to root P. If I write VRMS proportional to root T, that is correct, because for a gas, okay, MW constant. For a gas, I will write here, for a gas, okay, MW, okay, MW will be what? Constant, okay. So I can write this one V proportional to root T, but VRMS proportional to root T is false. This is not correct, okay. What the correct, okay, correct one is this, VRMS proportional to root P by rho, okay. This is the correct version, okay. But if I say only root P, then that is not correct, okay. So if I say VRMS, if I change pressure, then VRMS will change or will not change? If I change pressure, then VRMS will change or will not change? Yes. If I change pressure, then VRMS will change or will not change? I cannot say this thing because I know VRMS is not directly proportional to root P, okay? So I don't know exactly, okay? I have to see other parameter. Actually, if temperature changing, then your VRMS will change. Can I say this thing? This statement, can I say temperature change, then VRMS will change? This one okay? Okay. Can I say this one okay? Can I say like this? If pressure change, VRMS will change? Pressure change, VRMS will change. Can I say like this? Pressure change, VRMS change? Pressure change, VRMS change? I cannot say like this, okay? Can I say like this? Density change, VRMS change? Density change, VRMS change? No, I cannot say. Only thing I can say, so VRMS depends on temperature or any other factor. VRMS depends on temperature, okay? VRMS depends on temperature, okay? So if you have written these things, okay? So, with the pressure we cannot say. A lot of people, okay, take this one as correct, that is wrong. P by rho, okay? So what happens, sometimes you are changing the pressure, density also changes, okay? So we cannot say clearly. We have to take the, okay, consideration of temperature all the time. So right, VRMS depends on temperature. VRMS depends on temperature, right? This one. VRMS depends on temperature. VRMS depends on temperature. If you're written all the things, depends on temperature. It is independent of pressure. It is independent of pressure. VRMS depends on temperature. Okay, it is independent of pressure. This is the statement they ask. Okay, regarding pressure, which is correct? They will say regarding pressure. One statement we know that due to the transfer of momentum, pressure is there. Okay, they will say VRMS depends on pressure, which is wrong. Okay, so VRMS depends on temperature. It is independent of pressure. It is independent of pressure at constant temperature. It is independent of pressure at constant temperature. Okay, independent of pressure at constant temperature. What are the meaning of this thing? That if I change temperature, it will change, otherwise it will not change. Okay, so in your mind you have to install this thing that I will decide all the things from the temperature, not from the pressure. Okay, yes. If I say pressure, temperature both are given, then what will do? Pressure and temperature both are given in the question, then what will do? You will take pressure or you will take temperature into consideration. If pressure and temperature both are given, then we have to consider temperature. You can this line also, even though this line is very basic, okay? Right? If pressure, temperature both given, then consider temperature. If pressure, temperature both given, then consider temperature. Pressure, temperature both given, then consider temperature. Okay, now we'll do the things here. So we know VRMS depends on the temperature, not any other factor here. Okay, so I will ask the questions and okay, now so I will take various possibility. Okay, if I say at constant, okay, at constant temperature, if I change P change, okay, P change, VRMS will change or will not change? Okay, at constant temperature, if pressure change, VRMS will change or will not change? VRMS will change or will not change? You will say, sir, no change. Why no change? No, temperature constants, we can say VRMS constant. Okay, temperature constant, VRMS constant. Now we can say clearly. Okay, for a given gas, density constant, then VRMS proportional to pressure. Some for a given gas, density is not constant. Like if I take balloon, okay, if I take balloon, okay, and in this one, if I, okay, balloon I can compress easily. I can compress, na? So here volume I can change. Volume will change, density will change. I hope this is clear. Okay. Density is not constant for a, okay, gas all the time. We can change. Okay. So we can say pressure change, VRMS, okay, no change because temperature is constant. If I say, sir, volume change, if volume change, then also it will not change because temperature constants, we can say VRMS, okay, no change, okay, VRMS, no change. If I say next thing, at constant, okay, at constant pressure, if I say temperature change, if temperature change, what about the VRMS? VRMS will change or will not change? You can say now temperature changing, VRMS will change. 100% VRMS will change. And if I say here in this one, sir, volume change or density change, anything, okay? Volume change or density change. They can say volume or density, both are the same because remember just volume, volume is mass by density or density is mass by volume. So here we can say VRMS will change or will not change in this question. They will say at the constant pressure, volume doubled, volume triple. Now change or will not change? This one, last one, you want to tell. What you say about this question? It will change or will not change? In the last one, at constant, question will be like this. At constant pressure, volume of a gas double. volume of a gas triple, then what will happen? Okay, then we can see at the constant pressure, everyone knows, sir, V proportional to T is there. And this one is there, V proportional to T. See, volume is changing, then temperature automatically changed. And if temperature automatically changed, then we can see here VRMS will change. Okay, now VRMS will change. If I say next one at constant volume, we can say at the constant volume, okay, if they are changing the pressure, okay, so I can say at the constant volume here, temperature change. You can say, sir, temperature change, VRMS will temperature change, VRMS will 100% change. Okay, they will say here pressure change. Okay, and what you say about this one, last one? Okay, pressure change. What will be the VRMS? It will change or will not change? Here in this one, VRMS will change or will not change? VRMS will change or will not change? It will change, because we know that here they are saying the pressure, but you know at the constant volume, P is proportional to T. Means whenever you are changing the pressure, temperature automatically changes, and when temperature changes, we can say VRMS will change. Okay, so if you say that here in the first one pressure was changed, VRMS was not changed, but here pressure changed, VRMS is changed. So we are not deciding by the pressure, we are everywhere deciding by the temperature. Okay, so this thing you have to remember, everything we are deciding out of temperature, not because of pressure. Ready? Can we do some more question now? Some questions we can do. This is a theoretical question. Okay, clear? One question you can write. At constant temperature, pressure of a gas is doubled. Find percentage change in VRMS. Okay, at constant temperature, pressure of a gas is doubled, then percentage change in VRMS. What will be your answer? Percentage change in the VRMS, what will be the answer? We can say answer is going to be 0%. And why 0%? Because temperature is a constant, that's why answer is your 0%. Okay, so now we are ready for some questions on the VRMS. Yes, ready? Ready? Okay, so we'll write some of the questions in the VRMS now. Yes. Okay. Ready? So I can say now in this one that VRMS is proportional to root of T by MW. Okay. Okay, MW. For a gas, MW will be constant. Okay, so your VRMS proportional to root T also we can see, right? VRMS for a gas at temperature 27 degrees Celsius and pressure 2 atm is V. Okay, find okay VRMS for same gas at pressure 327 degrees Celsius and 380 M. Now, so here temperature is given as well as pressure is given. What we are going to consider here in this one? So we can say gas is same, so MW will be constant. MW constant, pressure, temperature both given. So we are going to take the temperature. We can say V1 by V2 will be equal to root of T1 by T2. Okay, V1 by V2 equal to root of T1 by T2. V1 we can say V, V2 we have to find. T1 I can say this is a 27 means 300 Kelvin. You have to take temperature always in the Kelvin. So 300 divided by 327, 600. So here becomes 1 by root 2. So V2 we can say, sir, this is nothing but the root 2V. Okay. So if pressure, temperature both are given, we have to take always Effect of, okay, we have to take all the time effect of temperature, okay. Then can we write next question now? In this question, only temperature I have changed, okay? Only temperature. In next question, I will change temperature also, as well as I will change your pressure also, okay? Temperature and pressure both I will change. So can we write question? Right. VRMS for hydrogen. VRMS for hydrogen at 27 degrees Celsius. This is the next question. Question number 2. 3, 4 questions will write, VRMS will be over. VRMS for hydrogen at 27 degrees Celsius is 2000 meter per second. Find VRMS for O2 at same temperature. Now here they are giving the same temperature and they are only changing the gas. Same temperature, only changing the gas. So now we can say temperature constant here. Okay. So we can say V proportional to how much, or 1 by root MW. So we can write in this one, sir, it will be V1 by V2 equal to, we can say, root of, okay, MW2 by MW1. And how to put the values? We can say V1 is 2000 divided by V2. You got the answer also before me? No one. Okay, root MW2 for the oxygen. What is the mass? For oxygen, mass is 32. I said in the, okay, 32. And for the hydrogen, it is how much? Hydrogen, it is how much your? 2. So 32 by means root 16, and root 16 is how much your? 4. So you say V2 sir becomes here 2000 divided by 4, which becomes how much your? 500 meter per second. Okay. So can we relate for any other gas also? At the same temperature, can we relate for any other gas? Can we do next question? Next one. Right. VRMS for H2. Now we'll write next question. This one is clear? Okay. So we'll write next one. VRMS for H2 at 27 degrees Celsius is V. Find VRMS for HE at 327 degrees Celsius. So now here there have been two cases in which temperature is also changing. T1 is the 300 Kelvin. T2, if you say 327 means, okay, this one is the 600 Kelvin. Earlier the hydrogen gas, so we means we can say mass, okay. M1, if I say MW1 is the 2, later on the helium, that is the your 4. So now we can see here V is proportional to root of T by MW, okay. Temperature and mass both are changing. What answer you got? Before I solve, I need answer from you. Before I solve, I need answer from you. Then only I will write. Now we can say this one, sir, we can write V1 divided by V2 equal to root of T1 by T2. And here I can write MW1 by MW2. Okay, let's put the values. So this is the V divided by V2 equal to T1 is how much your 300, T2 is how much your 600, MW1 is 2, MW2 is 4. Now we can say, sir, 3, 2, okay, 12, and here also 12. So this is the 1. So V2 is actually equal to V. V2 equal to V. We got this thing? Are we ready for next question now? Next question. In VRMS 4 5 questions means more than enough. Yes. Okay, next question now. Okay, means in this one temperature I can change the mass. Only these are the possibilities here. Okay, few things I can change. VRMS we have to do. Other things we'll write in the next class. So I will write add here in this one VRMS for O2 at temperature T Kelvin is V. If temperature is increased to 2T Kelvin, temperature is increased to 2T Kelvin, means temperature is doubled, okay, 2T Kelvin, gas dissociate. What is the meaning of dissociate? Basically, gas dissociates into atomic oxygen. Okay, means atomic oxygen means O2 becomes O. Okay, find new VRMS. So we can say, sir, O2 actually becomes here what? O2 becomes O. Okay, you can say 2O, but O2 becomes O. I am writing here. So now we can say here temperature was T, but here temperature is how much here? 2T. Here MW, if I say it was 32, but here MW will be how much here? 16. And we'll use the same thing that was actually V proportional to T by MW, means we can write in this one V1 by V2 will be equal to root of T1 by T2, and we can write here MW1 and MW2. Okay, so we can put the values. T1 is actually here T, T2 is 2T, MW1 is 32, and this one is how much? 16. You say, sir, this is the 2, it becomes 1 by 2, it means V2 is basically 2V1, which is actually equal to 2V. So can we do the question of dissociation also? Any question if they ask dissociation, H2 dissociate into H like this, can we do? Okay, can we do one more question? One more. One more. Okay. Right. Right. VRMS of a gas. VRMS for a gas. Okay. Here question. VRMS for a gas at 27 degrees Celsius is V. Okay, is V. Find how much temperature should be increased. How much temperature should be increased so that number one, VRMS, okay, VRMS increased to twice of initial value, increased to, okay, twice of initial, okay, value. Okay, this is the first part, and here then the second part, VRMS increased by, okay, increased by twice of initial value. Okay, now temperature they are asking. I hope this one is clear, language is clear. Here they are saying increased to means twice of initial value, and here increased by twice of initial value. Temperature they are asking. I can say, sir, here V1 is V. So here what is the V2 in this case? What should be the V2 here in this one? In this case, V2. Here you can say V2 should be how much? Here V2 should be V2. I'm asking. VRMS increased to twice means it should be 2V. Okay. But here if I say in this one V1 equal to V, here V2 should be how much here? V plus 2V means how much here? 3V. Here it should be 3V. This one is clear. Now we can say question is over here, because we can say V1 by V2 equal to root of T1 by T2. Now we can write V divided by 2V equal to root T1 means 300 divided by, okay, you have to put in the Kelvin. So now we can say here T2 will be equal to 1200 Kelvin. So change they are asking. So change we can say that will be the 900 Kelvin or 900 degree Celsius. Change is always same. Do you know this thing? Change is always same in the Kelvin and degree Celsius. 900 Kelvin, 900 degree Celsius. Here if I say, then you can say, sir, V1 by V2, okay? So I can put the values directly. So V by 3V equal to root of 300 divided by your T2, cancel. So 1 by 9 equal to 300 by T2. So now we can say T2 becomes how much? Your 2700K. So change, if I say change they are asking, so we'll be having 2400K, and change is always same, so we can say 2400 degree Celsius. And change is always same in the degree Celsius and Kelvin. Clear na? Can I write 2400 Kelvin as 2400 degree Celsius also? 2400 Kelvin as 2400 degree Celsius, can I write? Yes. Okay, because temperature change is always same. So today you can try VRMS questions. All the questions you will get, okay? All the question of VRMS you can get, okay? And this language will use a lot of time. Increased to and increased by. A lot of people are doing the mistakes in the increased to and increased by multiple chapters. We are going to use this thing, increased to and increased by. Now, okay, do your questions, all the questions, enjoy, okay? Enjoy does not mean, enjoy means, okay, enjoy with your studies all the time, okay? Here is your QR code, and bye, okay, bye, yes, okay, bye. It is, your QR is coming here, so, okay, you can get the things. Anything you want to ask? Anything? Okay, otherwise we'll do other things in the next class, okay? Here we go.